Thanks very much. Good afternoon, good morning, everyone. Good evening, wherever you're watching this from. Thanks for inviting me along to this, Gianni, Christian, Francesco, and everyone else involved. My name is Robin Moffatt. Some of you, if you've been around the Oracle scene for a while, may recognize this, my name from some OBIE blogs. I used to work in that space. I now work at Confluent, one of the companies behind the open source Apache Kafka project, who contribute to that and have our own distribution called Confluent Platform. And I've worked in data for kind of as long as I've been working professionally, really. Started a long time ago building data warehouses, building analytics platforms, making my way kind of like through big data into Kafka, which is where I work today. I do lots of blogging, I do lots of talking. I've even started a YouTube channel recently with kind of the COVID lockdown. Had to have something to entertain myself. But you can go and check those out there. All of the slides, all of the code that I'm going to share today will be online. I'll be tweeting about that. I'll share it with the aces at home as well. And we'll do some questions at the end if we get a chance. So I want to talk about Kafka, and I want to talk about Oracle, and how we can use the two together. And to start off with, I'd like to kind of set the expectations and understandings of what we're actually talking about. Now, I'm going to assume that most people on the call are familiar enough with Oracle for me not to kind of need to explain that. But relational database, we all know and love it. Kafka, on the other hand, not everyone fully grasps what it actually is. So I'm going to give a little introduction to it, and then we're going to dig into the good stuff about getting Oracle hooked up with it. So Kafka itself is an event streaming platform. Kafka itself is not just like a message bus or like a message queue or a DOM pipe to kind of like shift data around. Kafka is an event streaming platform. It's built around this very, very powerful concept of a distributed append-only immutable commit log. So like something happens somewhere in your business, in your systems, it's an event, and we capture that in this thing called the log. And there are various different APIs, and we've got consumer APIs and producer APIs. We've got integration APIs, which we're going to talk about today. And we've also got stream processing as well, which we're also going to talk about today. So Kafka is not just this thing that some people may think of it as, where it's just about like getting data from here and shoving it over there, and like it's scalable and fault tolerant, and that's really useful. It is that, but it's a whole bunch more as well. And I want to show you why that actually matters today. But it is very, very hard. It is just this immutable append-only distributed commit log. Something happens, we write it to the log. And it's a database crowd, so when I start talking about append-only immutable commit logs, you may kind of like some bells may start ringing, and that's kind of like for a good reason. Because what we're talking about here is capturing events into a series of things on an append-only log, which we can actually replay forward to rebuild state. And on this log, we kind of break it down into separate things for organizing and accessing the data, and we call these topics. So we have topics to do with people clicking on our website and all these events, and they clicked on this, and then they clicked on that at this time, and this was the user, and so on. Information about orders that people are placing, and they place this thing, and these are their details. But also, we capture within Kafka what we would term reference data or lookup information. Because when you think about our dimensional data, the way that it actually comes about, the way that it's created in this world, is still through a series of events. A customer joins our database, they register a profile on our website or whatever, that's a create. And you have the event that got created, and you have the state that goes with it. And that is the message that we capture on the log. It was a create, and it was this. And then they move house, and that's another event. And they move house to this place, and then they change their email address to this. And you have a series of events related to that particular customer. And you can replay those series of events to build out the state at any point in time. So if you're thinking again of like Kafka is like it's this specialist thing that's just for like streaming data, and I'm like working with databases and it's nothing to do with me. Well, if you distill down what a database is doing, it's very hard. It's a series of events. It's just that we're implementing it in different ways. And databases are about lumps of state, and Kafka is about taking those events and then making that data available as state or as a stream also. So we can capture all sorts of different types of data within Kafka, and there are very good reasons why we'd even want to do that. Within the topics, we can partition them, and partitions are our unit of scale. So you can scale out your throughput in Kafka by parallelizing the number of consumers reading from it within what's called a consumer group. And you can parallelize that. And as a distributed system, these partitions get allocated out across the many brokers that you can have to form a particular cluster. So if you want to try out Kafka, you'd start with it on your laptop and have a single broker. You take it through to production, you'd probably start off with a minimum of 3 brokers. And as you need to scale, you just scale out and your data gets distributed out with redundant copies of it spread out across those brokers. Now, messages within Kafka are actually just key value bytes. And this causes a slight learning, like a slight bump in the learning curve. Because particularly from a database background, which as I say, that's my background and probably quite a lot of people on this call, we're used to saying to a database, here is this data. And the database says, oh, thank you very much for that insert statement or that update statement. I'll take that and I will go and squirrel it away and store it on a data file, and you have no need to worry about like, how we're going to do that. We're just going to do it because you said insert or update. With Kafka, when we start writing to it and we start reading from it, we have to understand that Kafka itself just treats the data as bytes. So we then need to start thinking about like, how are we going to serialize those bytes? How are we going to actually get it from the producing application or device onto the topic, and how are we going to do that serialization? And when we start reading that data, how do we deserialize? How do we know which deserializer to use? Now, there's tons of libraries out there, there's tons of converters, so we're going to talk about how you use it in a moment, but it's usually just a case of like picking the correct setting, like we're going to use this one or we're going to use that one. But when you start designing these things and like, how are we going to actually build out a pipeline or an application, you've got to put a lot of thought into this. When it comes to reading data out of these topics, consumers read the data. The data does not get deleted when a consumer reads it. So any kind of like remaining ideas that you may have of Kafka is like this transient message queue. And like, oh, well, I know such and such message queue and I'm used to that. And you read the data and then it gets deleted. Or we declare a set of subscribers and when they've all read the data, the message gets deleted. That's not how Kafka works. The consumption of the data and the storage of the data are not directly linked. The data is stored by Kafka on disk, but it's got some clever like page cache stuff that goes on that makes it really, really quick. But the data is stored by Kafka. And a consumer comes along and says, I would like to read from this point in the log for the topic that I'm interested in. And it just scans forward. And Kafka says, here are all the messages related from that point onwards. And then you get to the end of the log. And Kafka is an unbounded commit log. So like you get to the end of the log and the consumer will just like sit there waiting for new messages to arrive. But those messages don't get deleted just because that consumer's read them. Because what if someone else wants to use that data? So someone else comes along and says, well, actually, I'd also like to use that data. So they go to Kafka and Kafka says, oh, I've not seen you before. So you can choose to read the messages from the beginning of the topic or just like as of now, or indeed any point in between, because we don't delete the data when it's read. And someone else comes along and they start reading from it and then they make a mistake in their processing, or they're taking the data, they're pushing it down to another system. Someone makes a mistake on the target system, it crashes, they need to rebuild it. That consumer just comes along and says, oh yeah, I read to like this point last time, actually I'd like to rewind to like midday yesterday and reprocess all of that data, or rewind to the beginning of the topic and take all of that data again. So the consumers are independent of each other. The consumers are independent of any behavior and deletion of messages. Now, we don't always want to keep all the data for all time. So Kafka lets you say per topic, how long would I like to keep the data for? Would I like to keep it for a week, 2 weeks, 2 years, 10 years? That's all absolutely fine, and Kafka does that. You can also say I'd like to keep the last, based on size, the last gigabyte, the last terabyte, however much you want to keep. You can also say I'd like to keep it forever. So an example of that may be our customer information. We don't want to kind of like start getting rid of customer information just because they've not updated their profile for like 5 years. They're still valid. They've just maybe not moved house or changed email provider for 5 years. So we have something called compacted topics. And compacted topics say, I'm going to keep the latest value for every single key, regardless of when I received the last message for that. So then you get your creates, your updates, and so on and so on. And if nothing happens to that particular key, then you still have the latest value available to you. So you can store the data based on how you want to use it in your systems and in your business. That was a very, very brief run through of what Kafka is. The rest of the talks are going to be about integration and Oracle and stuff like that. If you want to learn more about Kafka, go along to that URL, scan the QR code. I'll put it up at the end as well, and I'll share it and I'll tweet it and all the rest of it. But that's a really good set of books that you can download to actually go and find out a whole bunch more. And I'll also link to, in the notes afterwards, another talk that I did last week about Kafka like 101 from the ground up, going through all of these components in a lot more detail. But now let's think about what we want to do with Kafka and databases. We're here for the Oracle piece and the Kafka piece. What have they got to do together? There's two main reasons why people want to hook up a database and Kafka. One of them is for offloading data from that database to somewhere else. So we've got data sat in a database, it's maybe our transactional system. We'd like to take that data and put it somewhere else for analytics. So let's take our transactional system, take all the data off there, stream it through Kafka, and go and push it into S3, for example. Why are we using Kafka here if we've just got point-to-point? There's a couple of really good reasons. One is if we don't use Kafka, if we use, say, like database to S3, we're now coupling these things directly together. The database goes offline, the S3 bit can't pull its data. Or if we push into S3, S3 goes offline, the database can't push its data. And that's fine. We could like implement some custom logic to kind of like handle restarts and all the rest of it. But now we're directly coupling them together. And if we decide to change the database, or if we decide to migrate from S3 to something else, we need to change things, each piece is directly impacted by that. Whereas if we use Kafka, we implement more loose coupling between these things. Something happens in the database, it goes into Kafka. Something arrives in Kafka, it gets pushed to S3. If S3 is offline, that's fine. When it comes back online, well, then Kafka will continue to push that data to it. So we more loosely couple it. And Kafka is a distributed system, it's highly redundant and resilient, so then you don't end up with that. You have a theoretical single point of failure, but in practice, it's not. So it's much easier to manage and decouple these things. Kafka is also highly scalable. So if your database gets a massive burst of throughput, that's fine. Kafka keeps up with that ingest of data, it applies the back pressure as it needs to, and it sends the data to S3 as it wants to. But because we keep our data in Kafka, we can reuse it. We can say, well, transactional data, we've got like sales information being generated from all of our systems. It's coming out of our transactional database into Kafka. We're pushing it to S3 for the data science team. But then someone else comes along and says, well, I'd like to get that information from there. I'd like to get it to a different database. Don't ask me why, I just would like to. And that's how we tend to build systems nowadays, like all sorts of like different types of technologies going on. And we want to build something which is going to be flexible and loosely coupled. We don't want to say, we've got the data in the database and we've pushed it to S3. We want that data somewhere else. Well, I guess we could pull it from S3 into a different database. Or we could hook up to our original database and take its second feed out of it, which kind of like doesn't feel like the right way to do things. So instead we say, well, the database is our original source of data. It pushes the data into Kafka. Once the data's in Kafka, we can push it to S3. We can also say, well, let's push it down to a different database, or use it to drive an application that wants to subscribe to that information. But we have this more loosely coupled approach, which is much more scalable. It's much easier to evolve as you go through. The other reason people want to use databases with Kafka is because databases are a very rich source of events. As we kind of like hinted at earlier, the database's transaction log is like kind of related to Kafka's idea of a log of events. And so if we've got an existing application in our business and we're wanting to use that application to drive something new that we're writing, we won't say, well, we've got an EPOS system and it's in this monolith, it's underpinned by a database, and it's like, we're not going to go and touch that. We definitely don't want to touch that. We're not allowed to, or it's out of scope or whatever. That's going to keep on running. But we'd like to start building new services over here, and they're going to hook up and they need to be driven by events from that source. So when someone creates an order, we'd like to say, well, we're going to run a fraud check on it, or we're going to move the label printing piece out of there, and we're going to migrate it onto this new thing and chip away at bits of functionality. And we can do that by saying, well, we'll take our database, we'll stream the events out of there into Kafka, and then new applications can subscribe to those topics. When something happens in the source application, that drives an event onto our new application. And we can start using Kafka as the broker for messages being exchanged between new applications until we maybe even get to the point where we evolve away from the old one onto a new set of applications using Kafka and asynchronous communication between them. So there's different reasons why people want to get databases into Kafka, but it's a very, very common integration pattern. So let's look at how you actually go about doing that. The way that we do integration between Kafka, both systems upstream like databases and systems downstream like S3 or other databases or Mongo or Snowflake or wherever else is using Kafka Connect. And Kafka Connect is part of Apache Kafka. So Apache Kafka, it's Apache 2.0 licensed. Kafka Connect is part of Apache Kafka. And it's very, very easy to set up and use because you don't have to write any code. I was talking earlier on about producer APIs and consumer APIs, and there's Java libraries and C libraries and C++ and Python, and that's great if you want to do that. But if you just want to get data from here via Kafka into there, you can just say, well, here's my configuration. Here's the connector I would like to use. Here's the source of the data, and these are the tables, and off we go. So Kafka Connect, it's a framework, and it's a pluggable architecture. So you say, I'm going to specify a particular connector for my source or target technology. So you have sources, and you have sinks, you have converters, and the converters manage that serialization and deserialization that I was talking about. So as a user, you simply say, we're going to standardize on, we're going to use Avro, or we're going to use Protobuf. You could even use like CSV if you like feeling really daft. I wouldn't recommend that at all. But you just specify the converter when you create your configuration. You say, we're going to use this or we're going to use that. And it just means you can hook up your topics together. You can also do transformations as part of this configuration. And we'll see this in the demo that I'm going to show you in a moment, where you can actually say, we've got some data coming in. I would like to change the data type of these fields, or I would like to drop these fields from the payload. So we're ingesting EPOS data from our source systems. It's got like credit cards and addresses and all kinds of stuff that we don't want in our Kafka topic, because the reason we're bringing it into Kafka is to drive another system that doesn't need that information. If we start bringing it into Kafka, there's all sorts of implications. So instead we say, well, let's pull in that data on its way in. So it never actually hits the Kafka broker. We're going to drop out this set of fields, all the PII information that we just don't want to be dealing with. That then never actually makes it through to Kafka. We're just storing information that we want to. You can pick up all the different connectors and transformations and converters on the Confluent Hub. So you type in a particular connector or technology you want to, gives you the link, and you can go and download it from there. When you run Kafka Connect, it's also a distributed system just like Kafka. It runs separate from your Kafka brokers. So your Kafka broker is like your JVM process that's running on one machine or many different machines or Docker images or pods or however you're going to run it. Kafka Connect, same idea. You can have a single one if you want to, but you can scale it out both for throughput and redundancy. So you can say, well, I'm going to have two workers and the workload gets distributed across them. If you lose one of those workers or you want to scale it down, Kafka Connect rearranges that work for you. So Kafka Connect is the way that we're going to get data between systems like Oracle upstream into Kafka, and from Kafka down to other systems. And there's two different ways of doing CDC, which is what we're going to use to hook into Kafka Connect to get our data out of the database. And a lot of the time you say CDC to someone, they usually think of like, oh, transaction logs. But there's also another way of doing CDC, doing change data capture. And particularly with Kafka, it's important to understand the two different approaches that are available, because they've each got pros and cons. So the first type is query-based change data capture. And the way this works is you go to the database and you simply poll it to say, are there any new records based on this given predicate? So you can base it on timestamp, you can base it on an incrementing column that's like going up each time, and you simply go to the database like every half a second or every hour or whatever interval you want to configure. And it says, okay, here is my database. I'm going to poll it and I'm going to say, select everything from here where it's the timestamp column's greater than what it was last time. So the initial one's going to pull all of the stuff through, and then we pull it again later on. It says, select everything. It's not like, here's the additional record. So we pull across changes to the database based on just like polling the database. The second way is log-based change data capture. This is what people often assume what we mean by change data capture. And this is going against the transaction log of the database. And it applies across relational databases, including Oracle. And this is where we actually take the transaction log of the database itself and take each of those events. Like every time we do an insert or an update or a delete, that ends up on the transaction log. And we can take those events and mirror them into a Kafka topic. So we're actually taking those events as they get created into Kafka. So let's actually see what this looks like in practice. So we're going to have a look at getting data in from Oracle into Kafka, those two different ways, and what's the difference between it. We're going to look at taking that data and pushing it down to a different database. We're also going to have a quick look at some stream processing capabilities as well to give you an idea of the kind of things that you can do. We're also possibly going to see what happens when you do a live demo and you've not really finished it yet, because I was working on this just before. So fingers crossed it works, but you might get to see it crash and burn, which is always fun for the audience and not so much fun for the presenter. So over here on my terminal, I'm just going to check that Kafka Connect is running, because I was doing this just before we started. So Kafka Connect is running. Kafka Connect, like I say, it's a JVM process. I'm actually running all of this under Docker. So I'll share all of the configuration afterwards. Docker's brilliant because it's you can just spin it up on a different machine and it's just going to have the same environment. So you can take this demo and you can just run it yourselves on your local machines and actually play around with the different integration capabilities. So all of our different containers are running, which is good stuff. And first off, we're going to start in Oracle. And in Oracle, we're going to have a look at the data that we've got. So if you wonder why I keep doing this, it's because I've got my cheat sheet, which looks like this, which again, I'll share afterwards. I've got that on my bottom screen here, which is why I keep looking up and down. So in Oracle, we've got a simple table. We've got information about our customers. So we've got like their first name, their last name. We've also got information on their club status. Are they like a platinum customer, a bronze status customer, and so on. So it's a very small, simple data set. And we're going to take that data and we're going to pull it through into a Kafka topic. And we're going to do that two ways. So both of these are fairly long JSON blobs, which we're going to copy into here and show on the screen over here. And Kafka Connect uses a REST API for configuration. So you could use the curl or something like that here. You can use Postman. There's also Confluent Control Center if you'd rather have a web-based user interface. So here we're simply saying we're going to use a connector, the JDBC source connector. Where's my data? What's my JDBC connection? And how do I connect to the database? Which table do I want to get data in from? Which column am I going to use for the connector to try and work, have rows changed? So like, here's the update timestamp. So we're going to select all the data from this where the update timestamp's greater than it was last time we checked. And then here, a single message transforms. I'm not going to go through all of these, but what they do is they modify the data on the way in. So we've got an example where we're adding in some metadata, we're adding in some lineage information, we're changing the topic name, and we're also setting the key of the Kafka message based on a field, which is going to be important later on. So we run that, and Kafka Connect says, okay, I've created that. We say, well, that's good. Let's try for a second one as well. And the second one looks like this. So this is now using a different connector. This is the Debezium connector. So Debezium's an open source project. They've got connectors for different databases. They've got MySQL, they've got Postgres, they've got DB2, they've got Mongo, they've got Oracle in beta status. So what I'm showing you here is it's a beta version, and we'll see in a moment why it's kind of like beta. It uses the Xstream API under the covers. You still have to pay Oracle some money for the Golden Gate for big data adapter. But anyway, it uses Xstream, and it's another way of getting data out based on the transaction log this time. The previous connector is using the JDBC connector. It's polling the database instead. So here we're saying, here's how you connect to the database. Here's some stuff to do with the capture process and the Xstreams API. Which table do we want, or which tables don't we want? And we submit that, and it says, okay, I've created that as well. So then we say, well, let's just make sure that everything is running, because we want to make sure that it's running before we carry on. And it says it is. So we can use the Kafka Connect REST API to say, tell me which connectors are running, what's the status of them, what's the status of the tasks within them, and so on. Now, let's actually see the information that the connectors have brought across for us. So I'm going to head back to my first screen here. I'm going to split it and open myself two more windows like this. I can get Tmux to behave. And in the first one, we're going to have look data, which comes through from the JDBC source connector. So this is using a tool called Kafka Cat. It's just a Kafka producer consumer command line tool. It's fantastic. If you're using Kafka, go and use Kafka Cat. It's it's really, really good. You'll find it useful, whatever you're doing. So here we're saying we're going to connect to our Kafka broker here. We're going to pull in data from this particular topic. We're going to consume, and we want just the last message in that topic. So it says, okay, here's the last message. And we can see it's this particular topic here, and the key matches the ID, which is what one of those transformations we're doing. So saying, here's our payload. So here's our message. And it says the ID is 3, the first name is this, last name, email address, and so on. So we've got what's in the database in a Kafka topic, and that's useful. And now what we're going to have a look at is what Debezium gives us, which is the log-based change data capture. So again, Kafka Cat, but we're going against a different topic. And this again shows us just the last message, but the last message has now got more information. Again, the key is set to the ID. And you'll notice here, we've got a field called after, and nested within that, we've got, again, the actual payload as it is. We've also got more information, like which version of connector did it come from, what was the SCN, and so on and so on. And we'll see exactly why this matters now. So what we're going to do is in Oracle, we're going to go and set auto commit on. I spent ages debugging this demo and I've not got auto commit on. It's like, why is this change not coming through? So it's a while since I've worked with Oracle. Okay, so now we're going to insert some data into our database table. And if you watch the two at the bottom, you're going to see what happens. So insert the row. This one here is our JDBC connector, and it picks up the change straight away because the timestamp is greater than last time it polled it. It says, here is your payload, it's ID 42. There's the first name, the last name, and so on. Down here, Debezium has said, okay, here is your payload. Here's the key. Here's the before is null because there wasn't a record there before. After is the current status. You've got the LCR position. You've got all sorts of stuff to do with the capture process also available as the metadata. So an insert is kind of same. But what happens now if we do an update? If we go to the database and say, well, we've just created a customer and the cup status was bronze, but we made a mistake because obviously it's Reiki should be platinum status, so we do an update there. Again, we capture the update in the JDBC. It says, here is the key is 42. Here's the payload, and you'll see now the club status is platinum, which is what we'd expect. We've just made a change to it. There's the previous instance of it. So you can see two events, both are valid because they both tell us things about what happened. First, this happened at this time, then this happened at that time. You can replay the two together and actually get the series of events. And then down here, in the Debezium one, we can see here's our key, ID 42, and now here's where it gets really different. Because it says, well, beforehand, here is the nested structure. Before, it looked like this, where the club status is bronze, whereas afterwards, after we made this update, it says here is the after portion of it, and the club status is platinum. So when you do log-based change data capture, you get a much richer set of information. You find out not only something changed, but exactly what changed. What did it look like beforehand? What did it look like afterwards? And then we go along and we say, well, let's delete something from this table. So we delete one of the customers, and the JDBC one looks like this. Well, it looks exactly like this because the JDBC one can't capture a delete. If you go to the database and say, select all records that don't exist anymore, it doesn't really make a lot of sense. And it's Oracle, there's clever things you can do with flashback and stuff like that. But here we're just dealing with a bog standard JDBC connector. So we say, well, select everything where the timestamp's greater than what it was last time. Well, we can't select something that doesn't exist. Whereas Debezium says, okay, here is our delete. It says the key is 1, the payload is null. Okay, the key 1 now has no value because we've deleted it. And why is that even useful? Because if we've deleted it, we don't care. Well, a lot of the time we do care because if something's been deleted, that's still an event in our business. We want an audit trail of what's been going on. We want to be able to take that information that we had originally, retain it in the target system, but maybe mark it as logically deleted. So being able to capture deletes is very, very important as well. Now let's see what happens if we use this data and try and push it down to a target system. So again, we're going to use Kafka Connect. Again, we're going to go to a new screen here, and we're going to paste in some JSON. This time we're using a connector, the JDBC sync connector. So JDBC connector has got a source and a sync component. We're going to send it to Postgres. It's just a target data store. We could send it to Elastic, Mongo, Snowflake, S3, anywhere where you've got a connector for them. That's like most data stores, NoSQL stores, block stores, message queues, anywhere that you want to integrate with. It's just a Kafka topic. And this, again, if we take a brief diversion, is why Kafka is so powerful. Because once you have your data out of Oracle into Kafka, the world of technology is your oyster. You can send that data to one place, you can send it to 2 places, you can send it to many different places. You can use the same data over and over and send it to the most appropriate place, what you're trying to do with that data. You can keep it in Oracle. Oracle's brilliant for lots of things, but there are some things that you would prefer to do elsewhere, or a team that you're working with wants to do elsewhere. You can say, well, here is that stream of data. Go and do what you'd like with it. So here we're saying, well, let's take that information about our customers and push it down to Postgres. The JDBC connector, it can create the table for us. It can evolve the table for us. If we start adding columns in the source, it can add those columns in the target. So we go and create that. And we say, well, let's go and have a look at this data. So now at the Postgres prompt, we can say, show me the tables that we've got. And show me the data they've got. So select star from customers. It says, well, there is your data. We've got ID 1, Rika Blaze there. We've got Rick Astley over here, platinum status. So originally we created Rick and he was bronze status, then we changed it to platinum. And what we did when we created that connector was we said, update the rows using an upsert. So use the key, which we specified here as ID. So the customer ID is our key. Update it if it exists, insert it if it doesn't. And if we go back over to Oracle and say, let's update Rick and let's change him to gold. Okay, so we've made that change in the source database. We go back over to Postgres, let's select star from customers where ID equals 42. And doesn't like that. So we'll just do a select star because it's easier. And now it says, here's Rick Astley and their club status is gold. So we're mirroring in the target database what's happening in the source database. The JDBC sync connector will even handle deletes. And this, again, is why you would want to have that delete capture. But if you remember what I said, the JDBC source connector, the query-based CDC, can't capture deletes. So that's a good reason if you want to actually mirror the state of the source in the target, you would use a log-based change data capture, like Debezium, like Golden Gate, like whatever else. Okay, so that's a very simple example of Kafka Connect. Get the data in, 2 different ways, and then pushing it down, in this case, to Postgres. Let's have a quick look at some stream processing. So let's go and do this. So stream processing is one of those things that doesn't always seem like an obvious thing to do, but if you think about how you work with data in Oracle, in other systems, lots of the time you're taking data from one place and like you're batching it up and doing some processing and writing it somewhere else. And lots of the time that translates very naturally into some stream processing as well. So let's go and create ourselves yet another connector. So this connector here is actually just a data generator connector. This is again why Kafka Connect is so useful, because it's a framework and you can plug in connectors. In this case, it's a source connector. And all it's got is a little bit of code underneath, which just generates random data. So you say, well, where do you want to write the data to? How do we want to serialize that data? And again, it's pluggable. So you can say, I'd like to generate some random data and serialize it as Avro onto this topic, or serialize it as protobuf onto this topic. I don't have to write separate code to do it. I just say, well, using the same connector, I'll just plug in a different converter. And now let's go and launch ksql. Got lots of windows going on here, so let's clear the screen and that comes up. And now we're at the ksql command prompt. So ksql is built on top of Kafka Streams, which is built on top of Kafka. So Apache Kafka has got the Kafka Streams library within it. Again, part of Apache Kafka, just like Kafka Connect is. And then as part of Confluent Platform, ksqlDB is built on top of Kafka Streams. And it lets you use SQL to declare what you'd like to do with streams of data. So it starts off with, we're just going to say, show me what topics we got on the cluster. It says, well, you've got topics here, like we saw earlier, for customers and customers that we pulled out using JDBC. We've got a topic called page views. So let's consume that topic and let's say print page views. And it says, here is the contents of this topic. So it's just a consumer at the moment. We could use Kafka Cat for it or whatever else. And these messages, they've got a key and they've got a value. What time was it that someone looked at a particular page, which user, and what was the page? It's a fairly noddy set of random data, but it gives us this continuous stream of data. So now what we're going to do is we're going to declare ourselves a stream on top of it. So ksqlDB has got 2 primary object types. It's got streams and it's got tables. And to start with, we're going to create a stream, which is just an unbounded series of events, just like a Kafka topic, but with a schema. And this is where the serialization formats comes in. Because this data here, it's got a schema. It's got view time and user ID and page ID. And when I want to use that data, I don't want to go to the person who wrote that data and say, what are these fields? And is that an integer or is it an epoch? And is there a missing field here? Is there a default for that field? I just want to say, go and use this topic. And that's what I've done here. Create stream page views against this Kafka topic. And the value format is Avro. Because it's Avro, we've got access to the schema because it's stored in the Confluent schema registry. And when I say, tell me about this particular stream, it says, well, here is the schema for this stream. View time is a big int. It's the number of milliseconds since the Unix epoch. We've got user ID as a varchar, page ID is a varchar. So we've got access to the schema already, so we can start using that data straight off the bat. I'm also going to create myself a table here. So the table, again, we're using Avro. Again, we don't have to type in the schema. And we're saying a table sits on top of this Kafka topic. So in ksqlDB, all of the data that we work with is Kafka topics. We read from Kafka topics. In a moment, we'll see we write to Kafka topics. The only difference is how we want to model that data. So when we create a stream, we say, I'm interested in this unbounded series of events, like the fact data, if you like. If that's kind of like for your analytics background, we're talking about fact data. It's a stream of events. And then tables are basically our dimension data. It's a key value, it's state. So for this particular key, what's its value? What's its current state? So we're going to create a table called customers. Now we can say describe customers. And it says, well, there's your schema. And we know we've got a schema because we captured it, in this case, from Kafka Connect. It connected to the source database, to Oracle. It says, give me all the DDL for that table. I'll store that schema in the schema registry. And now we come to use it. In this case, our consumer is ksqlDB. It pulls down that schema from the schema registry. It says, here is your schema. Here are your data types. So it's very, very useful for building these low friction, loosely coupled pipelines. And we can query it. Okay, so let's go back up. Oops. Let's go to that original query that we ran in Oracle at the very beginning. On page up here, I'm going to say select the ID, username, whatever, from customers. And we're going to head over to, definitely got too many windows. I'm going to head over to ksqlDB. And I'm going to say select this stuff from customers. I'm going to say make changes, which I'll explain in just a moment. And it says here is the current state for all of the keys in ksqlDB, which is backed by a Kafka topic. So let's take this Kafka topic and let's apply a schema to that particular topic. So here's ID1 is our particular key. Here is the state for that key. Here's our ID 42. Here is the state for that key. And because we have the state for the key, we can actually enrich that stream of events. So let's remind ourselves to select star from page views, emit changes. This is our stream of events. It says for this particular user, let's just pause it so we can see what's going on. For this particular user, they just clicked on this particular page at this particular time. So we've got a series of facts coming along, but we'd like to know, well, who is user ID 1? Who is user ID 4? Who is user ID 9? And what's their club status and so on. So we can do this. We can run some SQL to say exactly this. Select the user ID, select the user's, the customer name, select their club status, the page that they clicked on. From this inbound stream of page views, from this Kafka topic, do an inner join to that customer's topic, modeled as a table, and do a join. We're going to do a replace function against the user underscore and just take the integer piece of that, join it to the row key of our customer's table. And it says, here is your live stream of data enriched with information about those customers. So user ID 3 turns out to be this person, they have bronze status, they clicked on that page, and that's a live stream of information. It scrolled by really fast at the beginning because we went back to the beginning of the topic of our page view data, consumed it from there, and enriched every single row along the way. Now it's just ticking over because this is the live data generator. And I can take that and I can persist it. So let's say, let's do create. So like in the database world, create table as select. Very common, very useful way of taking a set of static data and copying it to another set of static data. We can do the same thing with streams, except it's not static. Create stream page views enriched as, and then take the output of that select. So instead of dumping it onto my screen like you saw, write that to a new Kafka topic or to a new ksqlDB stream, which is underpinned by a Kafka topic. So we say show streams. We've now got a second stream here called PV enriched, backed by a topic of the same name. And if I now use my consumer, print PV enriched, it says, well, here is your Kafka topic. And it's exactly as it is before. Here's your user ID, here's your page view, but we've also added in the customer name and the club status. So we could take those page views, we could go and dump them in S3, we could write a Spark job to like pick up all of this information from a bucket and enrich it with lookups up to a database, and then go and write it somewhere else for our analysis. Or we could say, well, as we get page view information through from wherever, produced into a Kafka topic, we simply run this simple program here, which is a one-line SQL job, which runs continually and writes out to a new Kafka topic the enriched data. So it doesn't always have to be like, oh, we need real-time feeds. It's sometimes, well, why would we wait to process the data if we can just do it as it arrives? And with ksqlDB, you can run aggregations as well. It doesn't just have to be kind of just enriching and filtering streams of data. So here's an example, and this is what I was doing just before, so it may break. We're going to take information about the users, what they've clicked on, and we're going to aggregate it. We're going to say, how many times did a particular user click on a particular page? So here's our user ID, here's our customer name, their club status, and their account here. We're going to take it from the page views, inner join to customers as before, with a group by. And the very eagle-eyed amongst you will have noticed we did a create table, not a create stream, because we're going to create a table, which is our key value state. So our key is our user ID, down here is our group by clause, that's our key, and then the state is going to be this, it's going to be that count value. I can say describe PV ag. And it says, well, here's the schema. And we can select star from PV ag, unit changes. And it'll say any moment now. Here is, let's pause that. Here's your username. Here is their club status and how many times they clicked on that particular page. And we could use min and max in there to say when was the first time they clicked on it and the last time they clicked on it and so on. But what we can also do is we can take that aggregation and push it down to another system. So you say, well, we're interested in capturing how many times users have clicked on particular different pages, and we're going to store that in a database. So let's say create a sync connector here. So again, this is Kafka Connect, just using ksqlDB as a front end, using the JDBC sync connector, push this topic down to there, and our primary key is the concatenation, is the composite key of the user ID and the page ID. So we send that down to Postgres, and we say show connectors, and cross our fingers that it worked, and it says it is working. We say brilliant. So now we can go and launch Postgres again. Show me the tables. We've got a new table this time. Select star from PV ag. It says here is your data. So here's user ID 1, here's the customer name, status, and page ID. How many times have they clicked on it? You can see these values are increasing. If I filter that down, I don't know if we're actually going to get it to show data. It depends on the rate at which the data is arriving in the source system. But if I keep on querying that, you can see those values are going to change if I refresh it enough times or if we get bored. Well, we've got bored. But it's updating it in place. It's doing an upsert based on this composite of the user ID and the page ID. So let's try it once more for luck, and it's still not. So we've got new data arriving. It's rebuilding that aggregation, or it's updating that aggregation. We've just not had any rows arriving for page 22. We'll come back to that at the end, maybe. The last thing I want to show you before we go back to some slides and stuff is what you can actually do using these tables that we have in ksqlDB. So if we brief recap, ksqlDB is this SQL front end basically on top of streams of data within Kafka. We can model those streams of data as a stream, as just like a series of unbounded events but with a schema, or as a table, which is key value state with a schema. And those tables, we can actually materialize within ksqlDB, and we can query that state directly. And that's where the DB bit of ksql comes. And I'm aware of my audience here that's kind of like calling something like this a DB is going to raise all sorts of eyebrows, and to preempt the questions, it's not ACID and all this kind of stuff. But there is this notion of doing a key value lookup against state based directly on a stream of events held in Kafka, which is in itself very, very powerful. This isn't Oracle kind of like rebatch. This is not kind of, well, just like ditch Oracle today and use ksqlDB. They're completely different things and purposes. But where people are writing applications that need to do key value lookups against a series of events, being able to query that directly from ksqlDB is pretty useful. So let me show you. So we're in ksql here, and we're going to say we create a stream against our customer's topic. So previously I created a table against that customer's topic. So we said, take each key within that table and show me the latest value. Now I'm going to say, create a stream. I want to see every single event within that topic. And if we say select star from customer events, and emit changes, we're going to see all of the different changes. So we can say, here's Rick, and we created him status bronze, and then we did an update, and then we did another update. Those are all the different events. And events are useful. How many times did this user change their profile? When was the last time they changed it? When was the first time? And so on and so on. So events themselves are very, excuse me, very powerful. What we're going to do now is we're going to rebuild that table, but we're going to rebuild it as an aggregate. And the aggregation here is going to be against the string columns. I'm going to say, show me the latest value. So in a sense, it's like that create table I did before, but here we're using an explicit aggregation. So we're going to create that table. I put MV because we're basically materializing a view on top of it. Because what we can do is we can say, show me the state for this key. And you may have noticed I keep doing this emit changes. And emit changes basically means I want to do a push query. I want to, as the client of this data, receive any changes that are made to it, and the cursor will sit there and you won't get any changes sent to you. You won't get return of control because it will just keep on sending you those changes. And if we head over to Oracle and do an update, so let's change Rick back to platinum status. So we do the update in the database there. And we go back over to ksqlDB here, we can see the state has changed. Now is platinum. So we've got a table in ksqlDB mirroring the state of a table in Oracle. Because if I query that again, what's the current state for that particular key? It says, well, here is the current state. Okay. But you don't always want to subscribe to that stream of changes. You sometimes want to do this key value lookup. And that's what you can do using these materialized views, these kind of instantiated views within ksqlDB. So I say select star from here without emit changes. Just show me the value for this key. It says, well, here is the value for that key. Now we go back to Oracle and we change it back to gold again. And we go back to ksqlDB. We don't know that it's changed to gold. We've simply done that point in time lookup against that state. And then we go and run our query again. What's the current status now? Our current status is gold. And just as you can run it from within ksqlDB, you can also use the REST API of ksqlDB to query it that way. So I'm just going to run a curl call here because I'm not a particularly good coder. But if you're writing microservices, if you're writing your Java or your Python or your Go or whatever, you would use a REST call directly out to ksqlDB to say, what's the current state of this user? What's the current club status of this user? And say, well, the current club status of this user is gold. So it's just a key value lookup using a REST API. So that's a bit of a look at the kind of things you can do using Kafka, getting data in from Oracle, using Kafka Connect, using things like Debezium, using change data capture, pushing data down to other systems like Postgres, using things like ksqlDB to look at that data, to process the data, to filter it, to enrich it, to join it, to aggregate it. Let's wrap up with a few slides now. I'm conscious of time, and I'd like to do some questions if we get a chance to. But let's recap this really important difference between query-based and log-based change data capture, because they both have their strengths and weaknesses. Query-based is a whole bunch easier to get going with, because you just need a JDBC driver and credentials to select from the table. It doesn't let you track deletes. It doesn't let you track events that happen within a polling interval. If you're polling every second and 3 different events happen, you get what happened at the first poll and the last poll, and you miss those 2 intermediate events, which if you're driving applications by those changes, makes a massive difference. You also need to have a schema which supports this idea of updating timestamp or an ID column that's incrementing each time. So there's kind of several reasons why you wouldn't usually use query-based. Let's skip ahead to this one here. So if you're building event-driven applications, a lot of the time you're going to want to use a log-based change data capture. If you've got a service which is expecting to receive every single event from the source system, not just like the current state at the time at which we polled it, but every event, including deletes, then you want to use log-based change data capture. You get all of the data fidelity, you get all of the events, you get the before and after records, you get all sorts of good stuff like that. It is more difficult to set up. So if you're setting up X streams, you've got to do all that kind of stuff with DBA permissions. A lot of the time you're gonna have to pay for something like this. Debezium's open source and licensed as such that you can use against MySQL and Postgres and so on. But at the moment, the Debezium connector uses Xstream. And if you're using Xstreams, you've got to pay Oracle for it. So there are kind of good reasons for using it, but also these other considerations to take into account. Let us quickly talk about ksqlDB, because ksqlDB lets you take these streams of data that you've got going in and out using Kafka Connect, but actually build some really useful things against it. Because a lot of things that we do with streams of data are based on kind of like fairly common patterns. We've got data coming in and we want to simply alert against it. So we've got like a machine production line, we've instrumented all the robots, we've got events coming in from those robots all the time. We want to alert against them. We want to say, if a widget gets produced by a robot that's over a certain weight, we need to know about it. So select everything from this inbound stream where the weight is over a certain amount. Select everything from the inbound stream and do a count. So how many widgets have we created broken down by production line? What's the average temperature of the different devices? And if it's over a certain amount, raise an alert. Because the output of each of these selects can be to a Kafka topic, and then any alerting application subscribes to that topic, and it just gets an event sent to it when these different conditions are met. Or indeed, you can take this stream of data and push it down somewhere else. Create a sync connector to Snowflake, to sync connector to HDFS, to Mongo, to wherever you want to put your data for further processing. It's all based around the idea of consuming data from a topic. We write our SQL statement, which is going to probably do a create stream or create table as select and write it back onto a Kafka topic. We can daisy chain them and continue to process the streams further and further. So we enrich it and write it back, and enrich it and write it back. We can also say we're going to process it, like we saw in the demo. We're going to join between this stream and table and then write that down to a target system. Or we're going to use it to enrich the data to go and drive a service. But then we also said, well, we can sometimes write a SQL statement which is going to materialize the state within ksqlDB. So we've got an aggregate function in there, so we're going to have that state available within ksqlDB. And ksqlDB is also distributed and highly performant and resilient, and you've got redundancy and all the rest of that good stuff. So we can then write our applications that can do key value lookups directly against that state. And we could take an inbound stream of transactions against bank accounts and say, well, group it by bank account, take the transaction amount and do a sum across that to find out what the current balance is. And then our application, like a user on their phone, the back end of that application does a key value lookup. It says, what's the current balance for this particular account? So for account ID 42, what's the current balance? ksqlDB says, well, I've got that aggregate stored within my state store, and the current balance is this. You can do key lookups, you can do joins within ksqlDB. We saw that as well. I'm going to skip right ahead to this. This was the difference between the two different queries that I ran when I was doing the key value lookups. You can do a pull query, which is where you do a key value lookup and it returns control, and it tells you exactly what the value is now and it returns immediately. You can do a push query where you subscribe to a stream of changes. So a push query you would do against a stream of data. You've got your unbounded stream of data. And you could also do it against a table where you want to know when's this aggregate changing, or when's the values within our reference data changing, and subscribe to that within your application. So you've got two different interfaces for answering different questions of the same data. Hopefully that's been useful. Hopefully that's been enlightening as to what you can actually do with Kafka, with Oracle, with various other systems. I've kind of scratched the surface of what you can do, and I've tried to allude to different points of further interest. I've got some links that I'll share after this for further talks if you want to know more about specific things. Again, these books are a really, really good place to start. So if you want to go and find out more about the guts of Kafka, if you want to know more about the kind of like the foundational concepts of a log and why it's so very, very powerful, designing event-driven systems, all this kind of stuff, you get those books for free off our website. Scan the code, go to the URL. Confluent Cloud, Confluent who employ me, have enabled me to be here today, so thank you to them. We've got a hosted Kafka offering, and it's a managed Kafka offering. It's not just like, here's Kafka and you have to worry about it yourself. It's, here's a Kafka broker, we worry about it for you. We scale it and tune it and all the rest of that good stuff. You also have ksqlDB, you also have managed connectors there as well. So various offers and sorts of good stuff like that on the screen there. Again, I'll share the links afterwards. If you want to learn more Kafka, go along to developer.confluent.io. So like you've read the books, you've kind of like drunk the Kool-Aid, you're on Confluent Cloud, you want some examples of what to go and build. On the developer Confluent.io, some really good examples, there's blogs, there's tutorials, there's all that kind of good stuff. And then finally, the Confluent Community Slack group, there's thousands of people on there, lots of different channels for all sorts of different areas of Kafka and Confluent Platform. So come along and join the community there. These are the other talks that I was referring to as we went through here. So depending on what you want to learn more about, go and check out those talks. You've got the links there, and I'll share those also. With that, thank you very much for attending. Enjoy the next talk. And thank you again to Francesco, Gianni, and Christian for inviting me to this.
Thank you, Robin. You still have maybe 2 or 3 minutes to just take 1 or 2 questions live, and then maybe you can answer the other one in written form.
Yeah. Sounds good. So I'll have to go to the Q&A thing here. So for ingesting Oracle, ingesting in Kafka from Oracle database, is org mandatory, or can we do it without org as well? So you can use Oracle Golden Gate, and I didn't dig into kind of like the different ones you can use. So if you're wanting to log-based change data capture, there's Oracle Golden Gate, which is kind of like the main one. You've got Xstream API, which like sits underneath that and is licensed. Last time I checked, licensed the same. Oracle Golden Gate for big data. You can't just have Oracle Golden Gate. You have the big data bit as well. There's Click Attunity, Click Acquired Attunity. There's HVR. There's Strim. There's other companies that have also got tools that use the transaction log of Oracle database to get the events out. Some of them integrate better with Kafka and schema registry than others. I would strongly advise picking something which integrates strongly with a schema registry and doesn't have some like bespoke format that says like, well, here's our own version of a Kafka message with some schema data in. Like, you want something which supports Avro, Protobuf, and so on. In Kafka for the connecting string, how do we mask the password, which is shown as plain text in the demo? If you go to my blog, so armoff.net, there's an article there on how to use, I think they're called credential providers with Kafka Connect. And then you can have like a separate file or like password safe and stuff like that hooked up to Kafka Connect. With all of this stuff, feel free to tweet me. That's my Twitter handle up there, @armoff. If you didn't pick up any of these answers, or go to the Slack community and I can help out there. How do you take care of messages? How do you take care of messages so that it is not lost in transit if there's a billing? So basically, consistency of messages is down to the producing application. So the producing application can say, I need to know from either I'm just going to chuck the message over at Kafka and hope that it got there, which for something that's important, you probably wouldn't do. You can say, I need to know that it's definitely being written to disk by 1 broker or 2 brokers, or like all of the brokers. So that's a customizable thing based on whoever's doing that writing of the data down to the database. Does the source connector use database change notification? I don't know. I'm kind of like an Oracle analytics person. I dabble at DBA things, but Oracle database change notification, I'm afraid I don't know what it is. So I can't answer that one. Log-based CDC, are you pulling from the redo logs? If so, can this be used for security purposes, i.e. check for drop tables? I believe it uses the redo log with the same caveat that I'm not actually a proper DBA. And the different, so Debezium is the one that I've been using, and I don't know if it actually would log a drop table or not. You have to go and dig some more into that. We write to Oracle via Hibernate to a normalized schema. So would we get maybe 50 CDC events per domain insert? I don't know. I'm not familiar with Hibernate, I'm afraid. Sorry. Okay, I think that's all the questions. So let me check. No, okay. So thank you very much for everyone, and hope to speak to you all again soon. Thank you.